Hey everybody, welcome back. Today we're going to be discussing linear equations and linear functions. Let's begin. The graph of a linear equation is a straight line and can be written in various forms. The first form, known as the standard form, this can be written as ax plus by equals c, where a, b, c are all real, and a and b are non-zero. For example, a, b, c can take on the values a equals 1, b equals 2, and c equals 1.5, which would have an equation in standard form of x plus 2y equals 1.5. The second form, and most common form, is the slope-intercept form. And that can be written as y equals mx plus b, where m is the slope and b is the intercept. Or we should say the y-intercept. For example, y equals 3/2 x plus 5, where m equals 3/2 and b equals 5. If m is greater than 0, we say the slope is positive. And if m is less than 0, we say slope is negative. A positive slope, m, will have a general direction like so. A negative slope, m, will have a general direction like that. The third form is known as the point-slope form. If we have a point x1, y1, and another point xy, we can write the equation as y minus y1 equals m multiplied by x minus x1, where x1, y1 are points on a line. So m, again, is our slope. x1, y1 are points on the line. The fourth form is known as the function form and is written as y of x is equal to mx plus b, or sometimes seen as f of x is equal to mx plus b. This y in parentheses x is read as y of x, and similarly f in parentheses x is read as, that is to say that y is a function of x. Let us define a couple of things. The x-intercept is where the graph crosses the x-axis. If we draw a graph, this is x, this is y. The x-intercept is this point here, and we'll have coordinates x and 0. The y value will be always 0. On the other hand, the y-intercept is where the graph crosses the y-axis. If we draw a graph, x, y, the y-intercept is this point, and we'll have coordinates. X's will always be 0 and some y. There are a couple of special cases when looking at linear equations. First is when x is c, or a constant. Example, x equals 1. That will just be a straight line like this, a vertical line. The second case is when y is a constant c. Example, y equals -1. That will also be a straight line, but this time it will be horizontal as such. Let us look at a couple of examples. Example 1, draw a graph of x plus 3y equals 7. We recognize this is a standard form. Step 1, let us choose a point. Let x equals 1. If x equals 1, we have 1 plus 3y equals 7. Now we are solving for y. We subtract 1 from both sides, so we have 3y equals 7 minus 1, which is just 6. If we divide both sides by 3, we have y equals 2. We can say, therefore, that we found points 1 and 2. Let us look at another case now. Let x equals 2. Or better yet, let x equal -2. If x is -2, we have -2 plus 3y equals 7. Adding 2 to both sides, we have 3y equals 9. Dividing by 3, we have y equals 3. Therefore, when x is -2, y is 3. So far, we have 2 points. Let A be one point, 1, 2, and B be another point, -2, 3. If we proceed to draw our graph, and we label some points, 1, 2, 3, 4, -1, -2, -3, -1, -2, -3, and then 1, 2, 3. And we label A, which is 1, x, and 2, and y, 1, 2. And we label B, -2, 3. We have 2 points, and we can draw a line as such. However, we don't really know what this point here is, and this point here is. Let us say this point is point C, and this point is point D. Remember, our equation was x plus 3y equals 7. To find C, we let x equal 0. This implies that 3y equals 7, or y equals 7/3, or y equals 2 1/3. Therefore, the point C is just 0 and 2 1/3. Now, to find the point D, we set y equals 0. And we say x is 7. Therefore, that point is just 7 and 0. This point is 7 and 0. The other thing to notice about our curve is that our slope is less than 0 or negative. A hint is always to try and pick x equals 0 and y equals 0 as points and solve for the other variable. That is, if you pick x equals 0, you solve for y. If you pick y equals 0, you solve for x. Earlier, we talked about the slope m of a straight line, but we didn't really define it. To define it, let us choose 2 points A, x1 and y1, and point B, x2 and y2. If we draw a straight line, x, y, we can think of these points A, x1, y1, and B, x2, y2. The definition of the slope m, therefore, is just y2 minus y1 all over x2 minus x1. Or, sometimes we can think of it as the rise over the run. Or if we draw it again, this is the rise and this is the run. The slope m, therefore, is just rise over run. Let us look at a simple example. Find the equation of a line passing through the points a equals 0, 1 and b equals 2, 0. The first thing we need is to find the slope m, which is y2 minus y1 all over x2 minus x1. If we identify a as x1, y1 and b as x2, y2, then we have y2 is 0 minus y1 is 1 all over x2, which is 2, minus x1, which is 0, or minus 1/2. Therefore, we can write our equation as y equals mx plus b, where m is minus 1/2. Y equals minus 1/2 x plus b. Now we know from our point A, 0, 1, that when x is 0, y is 1. Therefore, we have 1 is equal to minus 1/2 multiplied by 0 plus b. This implies that b equals 1. Therefore, our equation is just y equals minus 1/2 x plus 1. Let us now look at how we can find the slope m if we're given a table of values. Let us consider the function y equals x. The table of values will be 0, 1, 2, 3 if we pick some x values, and y will just be the same, 0, 1, 2, 3. We can define m as y2 minus y1 over x2 minus x1. Or we can also say that m is change in y all over a change in x. And we can look at that as being comparing two successive y values with two successive x values. So this could be our change in y, and this can be our change in x. We can define delta y as our change in y, and delta x as our change in x. Therefore, if we look at change in y, 0, and change in x, 1 minus 0, that just gives us 1. Let us look at a slightly more complicated example where we have x, y, 0, 1, 2, 3, and 1, 4, 7, and 10. If we say this is our delta y and this is our delta x, and delta y is 4 minus 1, and our delta x is 1 minus 0, then m is delta y over delta x, which is 3 over 1, which is just 3. So our slope m is 3, which is a constant. And therefore, we can say that this is a linear equation. Of course, we would need to look at successive points all across our table. So we would have to include these points and these points. So for example, if we compared 7 and 4 all over 2 minus 1, we have 7 minus 4, which is 3, 2 minus 1, which is 1, which is also 3. So m is constantly 3 throughout. Our slope doesn't change. A linear function is one in which the power of x is 1 or 0. For example, y equals mx plus b. Our power here is just 1. Y equals 3x or y equals 2x plus 1. The power of x is 1. It could also be 0, as in y equals 3, where this is the same as writing y equals 3x to the power of 0. This is also a linear function. A nonlinear function would be y equals x squared, or y equals x cubed, or y equals e to the power of x, or y equals a to the power of x. We'll look at these, which are known as exponential functions, in another lesson. These are nonlinear functions. Let us now look at some cases what happens to the slope m as we increase the slope from 1 in y equals x to 10 to finally 20. So for y equals x, if we plot the graph, we get a straight line that goes through the origin. Now if we plot y equals 10x, we get a line that goes through the origin, but see how it's gotten 10 times as steep? And finally, if we look at y equals 20x, we can see that it's even steeper than y equals 10x. M equals 1, m equals 10, and m equals 20. And we all can see that m is greater than 0 here, and finally here. Our intercept in all three cases is just b equals 0, b equals 0, b equals 0. And that's just the point here where we say that is the origin. X equals 0, y equals 0. This brings us to the end of the lesson. I hope you enjoyed it. Please click like and subscribe, and hope to see you in future lessons. I'm hoping to get at least 1 million subscribers by the end of this month. Just kidding. See you later. Thank you. Bye.